Hello everyone. Please make sure that you have a paper and pen with you while we move on with this video. This video is going to show you some of the really basic concepts about a reaction. As you can see already here, this is a really simple reaction here where nitrogen gas reacts with hydrogen gas to produce your products, which is ammonia gas. Alongside with this reaction, you also see other things. You see this minus 46 kilojoule per mole, you see iron, you see the double-sided arrow, yeah? But all of these things are going to be addressed later. Okay, for now, let us just have a quick revision of some terminologies about the reaction. What do we call this? Molecules. And what do we call this as? So these two are the molecules that will be reacting together. Therefore, we call this as the reactants because they will be reacting together to produce your product. Yep. Therefore, in this reaction, reactants, you have two reactants. One is nitrogen gas, another one is hydrogen gas. Whereas there's only one product, which is your ammonia. What I'm going to do now is be going through with you the fundamental concept of how does this reaction really take place. Is it like magic where you put them together and they will automatically form into the products? Yep, so how does it really happen? Yep, so in this picture, you can actually see nitrogen gas and hydrogen gas contained in a container. Imagine if this is a container. While at the same time, I would like you to also imagine that this is you together with your friend. Yeah? So when molecules react together, it's pretty similar like you getting to know to your friend. Look, ask yourself, what must first happen when, before you guys could actually become friends? Simple enough. The very first thing that you guys must do is obviously to say hi to each other, to meet each other and to start to say hi and, to start your conversation. Well, it's pretty much the same for nitrogen gas and hydrogen gas, meaning the very first thing that must take place is this nitrogen gas must bang. The two of them must bang into each other. Now, bang is not the official chemistry term. The official chemical term to be used here is collision. So let us just start again. Hydrogen gas must collide with nitrogen gas before they can form the product. Get it? But then again, just pause for a while and look back. I'm sure you have met people whom you guys have became friends eventually, but you guys have also met people who you just can't click with and there are no friendships at all, right? Now the same happens here actually between the collision between nitrogen gas and hydrogen gas. There are two types of collision that could possibly take place. One is called productive collision, another one is called a non-productive collision. Well, I think it's pretty straightforward here, right? Productive collision would make sure that when the reactants collide into each other, you will have a product forming. In this case, when nitrogen gas collides with hydrogen gas productively, yes, you will have ammonia gas. In other words, when there is a non-productive collision, then no products will be formed. Yeah, so collision here is actually quite important. Now let's just pause for a while and I would like you to look at this picture for a while. Okay, look at this picture. Spend about 10 seconds to tell me of reaction 1, 2, and 3. Which one is collision and which one is productive collision and which one is not a productive collision? It's pretty obvious, right? So obviously this is a non-productive collision because there is no reaction. You see the products, no, sorry, not products. The molecules here are still the same as your reactants. In other words, no reaction. The second reaction, nope, non-productive as well. But look at the third one. Could you see products forming that are actually different from your reactants? Therefore, yes, this was a productive collision. Everyone is following so far, I hope. Right. Back to this picture for a while. Now, again, a quick revision. You have reactants, nitrogen gas and hydrogen gas, who will collide together productively to produce your product, which is ammonia gas. Now, just to add on one thing, when nitrogen gas and hydrogen gas collide, they will actually form an activated complex. Yep, it's actually an intermediate molecule that is very unstable when nitrogen gas and hydrogen gas collide together. So this activated complex will quickly, because it's unstable, you see, so it will quickly produce the product ammonia gas. But I have not actually addressed the most important concept here, that is, what really happens when nitrogen gas and hydrogen gas collide? What really happened in between? I'm gonna use this picture to explain to you what really happens in this reaction. If you noticed, I've added lines here. Yeah, lines and lines. All of these lines actually represent chemical bonds. Yeah, and every single compound would have bonds bonding the different atoms together. Like for example, you see these bonds bonding the two nitrogen atoms together to form the nitrogen gas. So in order for these two to react, forming the product, what must really happen first is for these bonds to be broken. Now imagine if you are breaking a chopstick, breaking a bond here. What is that one thing you need to break the chopstick? Yeah, you need to put in loads and loads of energy. Exactly. Therefore, when the bonds in nitrogen gas and even the bonds within hydrogen gas has to be broken, remember, energy must be applied. Well, if you look at the opposite, after they have broken the bonds and now they are gonna form new bonds here, what do you think would happen to energy? I repeat, energy is needed to break the bonds. So now you are forming new bonds. Guess what's happening to the energy? Yep, you're right. Energy will be released in this case. Okay, so please take note of the difference here. Energy is absorbed to break the bonds. Energy is released when new bonds are being formed. And the energy that we are talking about here refers to heat energy. Yeah, heat energy. Okay, so now we shall try to apply whatever we've learned onto a graph.